Hello everybody, in this video, we will be exploring how to take the derivative of an equation using implicit differentiation. This problem says, if a differentiable function y of x satisfies the equation below for y not equal to 0, then find dy dx. The equation below we have says x plus y to the fourth power equals 10. I want to take the derivative of this function with respect to the variable x, but I know that x is our independent variable and y is our dependent variable that depends on a variable x. And so we have to keep in mind that when we take the derivative of it, we have to imagine that y is a function of x. And so it's going to need the chain rule. When I take the derivative of this y term here, I need to make sure that I remember to multiply it by dy dx. We will dive into all of these steps as we move along to figure out how to solve this problem. Notice that x here is our independent variable, while y, as usual, is our dependent variable as it depends on whatever x is. So first, I'll take the derivative of x with respect to x. Of course, using the power rule, we know that's just going to be the number 1. Next, I'll take the derivative of y to the fourth, but with respect to x. If it weren't with respect to x, it would just be 4y to the third power, but it is with respect to x, and so I have to use the chain rule, and so that gives us this dy dx, which is just telling us that I just took the derivative of something that's dependent on another variable. All of this here is just the derivative of our y to the fourth term. I like to simplify it in my brain by just thinking, whenever I take the derivative of my dependent variable, to make sure to just slap on that dy dx. We're not done yet. I still need to take the derivative of this 10. 10 is a constant, so we know when we take the derivative of it with respect to x, it's just going to turn into 0. Nice. And so what do we notice here? I took the derivative of this entire equation here with respect to the variable x, and inside of that equation, I see dy dx, which is what we're looking for. I can think of dy dx kind of like a variable that I want to solve for. And so if I want to find dy dx, then I need to get rid of whatever's keeping dy dx from being by itself on this left side of the equal sign. That includes the 1. I need to get rid of that 1. I also need to get rid of the 4 and the y to the third power. Using reverse order of operation, I guess we'll first get rid of this 1. So, of course, the 1 is adding, so we have to subtract it to both sides. It's gone. Nice. What do we have left on the left side? I have my 4y to the third power times dy dx. Let me color code just so we can keep track of the main character of this problem, our dy dx. On the left side, I have -1. I almost have dy dx all by itself. I just need to get rid of this 4y cubed. It's multiplied, and so of course I'm going to divide it out. If I do it to one side, I do it to the other side. And so what do we see? We see that we've isolated dy dx, which equals -1 over 4y cubed.